Things that we have to talk about today. First of all, you should be on page 11. We're talking about how to calculate and interpret a residual. Now we're going to talk about residual plots, and then we're going to talk about if an observation is influential or an outlier. We're going to talk about the coefficient of determination, and we're going to talk about standard deviation. We are spending 3 days on this section, so we're going to do those first 3 bullet points today, and then the next 2 we'll do on Wednesday probably. Like I said, this section's confusing, so if you have a question, stop me when you have the question, rather than letting me teach for another half an hour and then you getting super confused. Yes.
So this section isn't on this one.
There is one question from this section.
Oh.
That is not difficult.
Which bullet point is? Can you tell me?
Like, kind of the first one.
Okay.
Okay. So, first thing we're going to talk about is how to calculate and interpret a residual. So, a residual is y minus y hat. So write that down. That's important. Y minus y hat. It's the difference between y is what actually happened, and y hat would be what was predicted to happen. So it's the difference between what happened and what was predicted. If your residual is positive, that means that y is greater than y hat. So it means your prediction was too low. If your residual is negative, then y is less than y hat, which means your prediction was too high. Visually, what this looks like on a graph is you have all these points. You have some line of best fit. This is a residual. It's the difference between what happened and what was predicted. That's a residual. That's a residual. That's a residual. So each point has its own residual. Residuals are really related to deviations. So if you remember, I think it was from last chapter, we talked about y minus y bar. Or it was x minus x bar.
Sure.
Yeah. And we talked about how that sum was always equal to 0. The sum of the residuals is also, for the same reason, always equal to 0. Okay, so I'm going to ask you to calculate a residual. So this is on the top of page 12. If you flip to the top of page 12, the data set that we are looking at looks at ACT versus the percentage of low-income students. So the percentage of low-income students was the X, and average ACT score for the school was the Y hat. This is the regression equation that you're given. So the question that I'm asking you here is at the bottom. Calculate and interpret the residual for the school that has a low-income percentage of 2%. Okay, so first thing that it tells us is our low-income percentage is 2%. We want to calculate the residual. Do you guys see where I'm looking on page 12? Guys, this is right at the top. And then I added this question that you don't have.
Oh. Sweet.
Oftentimes I have more than you do, okay? You got to figure out where to take your own notes.
Good.
So, residual, there's no symbol for residual, you just write out residual, is y minus y hat. Okay. Y is the actual ACT score for a school that has a low income percentage of 2%. If you notice, on page 12, you have all of these unusual observations that are listed. If you look at the first one, it says observation number 6, and it says low income 2. You guys see that? Mm-hmm. And then it says ACT of 26.8. That 26.8 is your Y. Now to find y hat, you actually have to substitute 2 into the equation. So to find y hat, I would do 22.7 minus 0.0754 times 2. And that is 22.536. So 22.536 is the ACT score that we would predict for a school that has 2% low-income students. When I subtract those, I get my residual to be 4.264. Okay, that's the calculating of the residual part. We also need to interpret it. Our residual is positive, which means that our prediction was too low. So our school scored 4.264 points higher on the ACT than what the line would have predicted. So writing that out, this school with 2% low-income students scored 4.264 points higher on the ACT than what the least squares regression line predicted. Questions on residuals?
There's no units, right?
It's going to be whatever the y units are.
So what you have circled in the blue, should it have what points under that?
Yeah.
Or, okay.
Yeah, so the units are, I'm going to say ACT points. Okay. Now, you might be asked to calculate a residual, but more important than that is all of the residuals. So generally what we do is we look at the residuals from all the points. So that's what we're going to do next. Next, we're looking at residual plots. A residual plot helps us determine the appropriateness of our least squares regression line. You want to write this somewhere. Maybe 11 or 12. I don't care where. Write it somewhere. A residual plot helps us determine if our line is a good fit to the data. So it determines the appropriateness of a specific line. Not a linear relationship in general, but our specific least squares regression line. If our specific regression line is a good fit, then there's going to be no pattern in the residual plot. The residual plot will look completely random. There are two ways to create a residual plot. This is the one that I use most often. X goes on the x-axis, the residuals go on the y-axis. The other way is putting y hat on the x-axis and then the residuals on the y-axis. Either one is correct. I use the first one because it's less work. If you do the residual plot the second way, you have to find all those y hats. I guess you got to find them anyway, though, to find the residuals. So residual plot's going to be a scatter plot. Now, these two are bad patterns to see in a residual plot. If you have a curved residual plot, that tells you that your original data set is probably curved. It's not linear. So if you see a data set that, or a residual plot that looks like this, again, this being the residual plot, so like x versus the residuals, then your original data set's probably curved. If you see a fan plot, I'm going to do the best I can to draw this, but a fan plot, it's where your residuals are close together and then they slowly get more spread out. So this is a fan plot. This is bad because here your points are really close to the least squares regression line. Here they're really far away. So that means that your linear regression is not a good fit to the data. So something that looks good, that's good. that says our line is a good fit to the data. Now, as you can probably tell, constructing a residual plot is kind of a pain in the butt because you have to find all those residuals. Remember that a residual is y minus y hat. So that means for each point you would have to find each individual y hat, and then you would have to subtract all of them. So it's kind of a lot of work, so instead I expect you to do it on a calculator. So I'm going to show you that right now, but this is going to be hard to remember, so I need you guys to follow all the steps that we're going to follow. But we're going to look at one thing before we do that. Any questions before we go on? Okay, if you look at page 12, you have these scatter plots. The one on the upper left plots low-income students versus the ACT score at that school. The one on the right is the same scatter plot, but the line of best fit is on it, the least squares regression line. This one on the bottom left plots low-income students versus the residuals. So this is X versus the residuals. The one on the right plots Y hat, the predicted ACT score, versus the residuals. So if you want to determine if a data set is linear, the first thing that you're going to do is you're going to look at the scatter plot. So if we look at our original scatter plot up here on the left, does this data set look linear? Yeah, it could be. We don't have reason to doubt that it's linear. It looks like it might have a moderate or moderately strong linear relationship. After you look at the scatter plot, what else can you look at? Well, yes. Not what I was looking for, though.
Regression.
That is separate from the scatter plot. What else helps us determine if a data set is linear? Besides looking at the original data. R. R. So the first thing you're going to do is look at the original data set. Then you're going to calculate the R value, which in this case is negative 0.847, which indicates a strong negative relationship. Third thing that you're going to do is you're going to look at the residual plot. Does this residual plot look like it has a pattern of any type? No, it looks pretty random. So because we have a linear scatter plot, and we have a strong R value and a random residual plot, we would say that our line, so this line specifically, is a good fit to the data set. Questions before I show you how to do this on the calculator?
So we want our residual plot to be like really random.
Yep.
Cast.
Okay. Take out your calculator. We're going to look at the same data that we looked at last week. So in this one, I want you to put 1, 2, 3, 4, 5. Please make sure that you do every single step that I tell you. If you skip a step, then you're going to mess this up. So put 1, 2, 3, 4, 5 in list 1. In list 2, put 2, 4, 6, 8, 15. And then I would like you to do the least squares regression. So I want you to do stat calc number 8. This time put in L1, L2, but don't put in the Y1 part, because I don't actually want it to graph the line. And you should come up with that. We all on the same page so far?
I have a question. How do you get the R value to turn on? Because I don't know. I did mine, but it's not there anymore.
Did your calculator die?
Maybe. I don't know.
Did you replace the batteries? Then it died. So the second catalog. Diagnostics on.
Why do we keep putting the L1 and L2 thing? Because like when I do it just like this, the same thing pops up.
Yeah, so I was not 100% truthful with you all. If you put in lin reg, it'll do it for you. Now, the reason that I have you put in L1 and L2 is it specifies to the calculator what your input and your output are. So if you don't put anything, if you just put lin reg, it's automatically going to grab list 1 and list 2. So if you decide to like switch the order, or if you decide to use different lists, then you have to specify what list you're using.
So if I'm choosing L1 and L2, like in that order, I don't have to really do it.
Correct.
Or should I still do it? Just
You still should, just for good practice.
squeeze.
So we're all on the same page so far? Yeah, okay, good talk. Okay, go to your first stat plot. And turn this plot on. Now, the way that we are going to graph our residual plot is we are going to graph X, which is in list 1, versus the residuals. So that's what we need to tell the calculator to do. Yes?
How do you get the stat plot?
Second y equals.
Oh, okay.
Okay, so make sure it's turned on, make sure you have the scatter plot chosen, and make sure that your X list is L1. Now, this is what we need to change. If we do L1 versus L2, it's plotting X versus Y. We want X versus the residuals. So highlight over list 2 right here, and then is A flashing the alpha lock? Turn the alpha lock off, so hit alpha. Wait, what?
You know, my age just wasn't flashing, so.
Okay. Then I want you to hit second list. And you should see this list RESID. That's a list of the residuals. So go down and hit enter. And then your stat plot should look like this. So now your calculator is graphing L1 X's versus the residuals. And hit zoom 9. You should get that. This is the residual plot now. Does this residual plot look random?
Not really.
No. Particularly if you decide to ignore that point. Now there's a clear pattern. So this would indicate to us that our regression equation is not a good fit to our data.
Mine just says error again.
Did you do the linear regression?
Yeah. Yeah, no, I have everything we need.
Go to?
Wait, why'd you cross out the one right there? It's not good?
No, so I crossed out that point because a lot of times people will look at that and say, well, yeah, it looks pretty random. But when you just ignore that point, it's clearly not random. Okay, in homework 3, you're going to have to construct a residual plot or two. On the AP test, you will never be asked to. On a quiz or a test for me, you will never be asked to. But you are going to be asked on the homework. And on the homework, you are also going to be asked to calculate residuals. So it's going to give you like 10 data points and say calculate the residuals for all 10 of these. That's a lot of work, so I don't expect you to do it by hand. I want to show you how to get to that list again on the calculator. So right now, quit out of the graph and just look at the blank calculator screen. Do we all have that? Okay, go to Stat and edit your lists. So you're at list 1 and list 2. I don't want you to mess those up, so go all the way to the end, which is probably list 6. Yeah? Now, highlight over list 6 so that the black box is on list 6. Hit second list. Find that residual list again and hit enter. Now you should have a list of all the residuals.
Is it 1, 0, 1, 2, 2?
I have no idea.
Yeah, 1, 2, 3.
You can do a list 3 if you want. That's fine. I normally use lists like 1 through 4, so I try not to mess with those.
Oh, look.
What?
9. So,
I don't care where you put the residual list.
you understand.
Okay, One thing that you need to be very, very careful of though, listen to this carefully. Your calculator calculates those residuals after you do the regression. So if you, right now, change all your data on list 1 and list 2 and then don't do anything else, the residual list is going to be the same. Because it's based off of the last regression that you did. Is that clear? So you have to make sure that you do the regression first before the residuals.
So if you were to ask us like on a homework, like calculate the residuals, what like kind of work do you want us to show?
If it's one residual, I want you to show the work that we did. The y minus y hat, show me how you found
Okay.
y hat.
But if it's like 10.
Then show me that once and then copy the rest off the calculator.
Okay.
Okay, we have one more thing to talk about and then we have an example to do. Last thing that I want to talk about is the difference between influential and outlier. An outlier is a data point that is set off in the y direction. An influential point is set off in the x direction. So an outlier is set off in the y direction, influential is set off in the x direction. So this, let's say this is our data set and that is our least squares regression line. A point up here is an outlier. Set off in the y direction pretty far. A point set off in the x direction, like over here, would be influential. Notice that an influential point can follow the trend. So this point follows the rest of the trend, but it's influential because it's far in the x direction from the rest of the data points.
What if it's like influential and like all the way down? That's really both.
That could be both, yeah. The further that a point is set off in the x direction, the bigger role it plays with the least squares regression line. So that point is called influential because it probably influences r and or the slope. So there's no way to test for an outlier that we're going to do. If there's a point that looks like an outlier, you're going to call it a potential outlier. The way to test for an influential point is calculate r and then calculate the slope, taking into account all of those data points. Then delete that point and calculate them again. If either one of them changes drastically, then that point is influential. So if you do the regression with that point and you get an r value of 0.5 and then you do it again and you get an r value of 0.3, that point is influential. Okay, any questions with residuals, residual plots, influential, or outlier?